This lesson deals with a little technical piece of something that some curricula make students go through. I'm just going to do it here and just be swift about it. The text actually explains it all in further detail. So they ask questions like, find a quadratic whose formula is crosses the x-axis at x equals 2 and x equals 5. So I want some sort of quadratic that crosses at x equals 2 and 5. Write down a formula for such a beast, 5 and 2. Well, my answer is, they've just given me two obvious interesting x values. So let me just make interesting x values happen. X minus 2, x minus 5, y equals that. And let me just check, I might want to do a plus or minus something over here, but probably not, because when I put x equals 2, they want me to have 0, got it. Putting x equals 5, they want me to have 0, got it. There is an answer. Actually, so is 3 times that answer, or so is the square root of 17 times that answer, or negative 1/10 is an answer. So it doesn't matter what the steepness factor is, they're all fine answers. Okay, so that's the first little point, and they'll make you practice like 50,000 of those examples. But the question could be more interesting in a sort of contrived way. They might ask, find a quadratic that crosses the x-axis at 2 values again, but then make it awkward numbers, like x equals 3/7 and at x equals, say, 2/5. And they're going to claim that they want all the numbers involved to be integers. All right, well, I'll do my trick first of all. Since these two numbers are spelled out to be interesting, x minus 3/7 times x minus 2/5 is a quadratic that crosses the x-axis at those two fractions. Put in those fractions, the output's 0. But I get to choose any steepness I like. And they say they want no fractions involved, it's everything to be integers. Well, what if I multiply by 7, the steepness is 7, I can see that actually I'll get 7x in here times 3/7. I'll make this friendlier. I'll still have this fraction over here. Let me also multiply through by 5. I'll put the 5 at the end. So I've got really a steepness factor of 35 here. 7 times 5 is 35. And what quadratic is this? Well, 7, if I sort of, unfactor, unexpand, whatever the word is, do distribution rule backwards. 7x minus 3 still times x times 5 and 2/5 times 5, 5x minus 2. Beautiful. There is a quadratic that crosses the x-axis at 3/7 and at 2/5, and if I were to expand it all out, nothing but integers appear. All right, very brief. I don't want to spend too much time on this because it's just kind of contrived. But it's a little technique, it's kind of fun. It just actually does re-emphasize the idea of interesting x values. So I know, they're interesting, I guess. All right, thanks.